This is 1-4 Measuring Angles, Geometry with Mr. Waddell. 1-4 Measuring Angles has the essential understanding that you can use number operations to find and compare the measures of angles. The DODEA standard that goes with this lesson is that we will demonstrate understanding by identifying, giving examples of undefined terms, axioms, theorems, and inductive and deductive reasoning. The key concept is the definition of angle. An angle is the figure formed by two rays having the same endpoint. The endpoint is called the vertex of the angle. The rays are called the sides of the angles. So with the figure AB as a ray and AC as a ray, the common endpoint is A, and so we can name it with the vertex called angle A, right here. Angle A, there's the vertex. With a point on each ray, we can use angle BAC, starting with this point on the ray, BAC, or we can start with C and go CAB. So angle BAC or angle CAB. We can also use a number that's written here and call this angle 1. Note this in green is the measure of the angle, and we're going to talk about angle measure in just a moment. When you use 3 points to name an angle, the vertex point must be in the middle. A is in the middle, A is in the middle, there's the A, it's the vertex. Okay, more definitions. The interior of an angle is the region or area that contains all the points between the sides of the angle. In this case, the interior has been colored blue. The exterior of an angle is the region containing all of the points outside the angle. In this case, it's colored orange, or kind of orange color. Postulate 1.7 is called the protractor postulate. It's very similar to the ruler postulate. Consider ray OB, which is laid along an edge of a protractor, and the point A somewhere out here on one side of ray OB. Every ray of the form OA, and here's ray OA right here, can be paired with one real number. And since I'm doing one ray to one real number, we call that pairing 1 to 1. And it can pair from 0, which is over here, all the way around till we get to 180 degrees. When you measure an angle, the measurement is indicated by using a small m. So in the example above, this is read measure of angle AOB, and it's 123 degrees. So here's 120. Now you're using this part of the protractor because it starts at 0. There's 120, 121, 122, 123 is where this goes through. And this, it is an equal sign because it is a number. The key concept next is types of angles. We have 4 different kinds. We have the acute angle, the right angle, the obtuse angle, and the straight angle. Here's the description, the diagram or picture of each one, and with a statement below it. An acute angle has a value that's greater than 0 but less than 90. A right angle has a measure of exactly 90 degrees. An obtuse angle is an angle whose measure is greater than 90 but less than 180. And a straight angle has a measure equal to 180 degrees. Congruent angles. Angles that have the same measure are called congruent. This means that if the measure of A is equal to the measure of B, now let me restate that because I should have said angle. Measure of angle A is equal to the measure of angle B, then angle A is congruent to angle B. Now, I repeat, numbers are equal, figures are congruent. Now, if angle A is congruent to angle B, then we know that the measure of angle A equals measure of angle B. We mark the interior of the angles that are congruent with arcs to show that they are congruent, and I have an example for you. In the figure below, you find 4 lines intersecting in several different ways, and the points on the line are named and the intersections are named. So this intersection is called M, this intersection is called I, this one is G, this one is H, that one is J. So the red arrows are pointing to 2 congruent angles, and those are small arcs. And every time we have an angle that is congruent, we count how many of these arcs there happen to be. So if this is the first angle I'm talking about, then it gets 1 arc. This is the second that I'm talking about, so it gets 2. The third one would then get 3. So name the indicated pair of congruent angles. It's angle KJL, KJL, and angle MJI. We could have said MJG, would have been the same thing. Okay, now these two, name these. I'll give you, okay. Make sure you understand why those happen to be what they are. And lastly, so this one is angle JIH. It could have been JIQ. This angle is MIG. It could have been PIG. Same angle. Notice the different number of arcs and how the angles are paired. Alright. Postulate 1-8 is called the angle addition postulate, and it allows us to take small angles, add them together to make larger angles, or to take a large angle and break it into smaller angles. So if point B is in the interior of angle AOC, so here's angle AOC, so I've marked the interior green, then measure of angle AOB, which would be AOB, so let's click and make that happen, alright, plus the measure of BOC. Now this means I can add these two angles together to get the original measure of AOC. Now, equal for numbers, congruent for figures. Alright. Remember, M means measurement, and that it is a number. Using the angle addition postulate, if I tell you that the measure of angle RQT is 155 degrees, What are the measures of angle RQS and angle TQS? Well, I've put a value here, but I've used a variable, and I'm going to give you a hint that this one plus this one equals 155. Here are the answers I want to see you solve for x, substitute back into this, and see if you get 72 degrees and 83 degrees. This is the end. Have a good evening.